Our particular problem in the producers and consumers, having to do with mutual exclusion, is the following thing. Suppose we have multiple producers, right? And they're both trying to produce characters into a buffer. So I'm having lots of people producing information that we have a single consumer for, right? So we have lots of producers, and they all want to manipulate the buffer themselves. And you can see what they do is that they're in the process, there's a sort of a two-step process. You put something in and then you change the pointer. And the trouble is if these guys interleave in the wrong fashion, like so, we can end up with reusing the same location twice and then leaving a blank in the buffer. So this ends up putting the character C in the same location of the buffer, but then incrementing the in pointer twice. So there's an example of interleaving of these shared variables, which is the buffer itself and then the in pointer, which is shared among all the producers, of interleaving that we want to avoid. So we need to use having some way to prevent this particular piece of critical code from being executed by more than one procedure at a time. And the way we're going to do that, we're going to introduce this mutual exclusion semaphore, which we almost always conveniently name mutex for mutual exclusion, right? As before, or a lock or something like that, we initialize it to 1, indicating we're going to allow one piece of the code. And you can see we do a wait and a signal, okay, around the code. So any of the producers that are busy manipulating the in pointer, okay, are waiting on the mutex. And any consumers that are busy waiting on the, want to manipulate the out pointer, use the mutex to guarantee that more than one consumer isn't in that critical code at the same time. So this code actually implements an unnecessary precedence constraint. What is that unnecessary constraint? Right. The idea here is we're trying to prevent multiple producers from screwing around with the in pointer at the same time. Over here, we're trying to prevent multiple consumers from screwing around with the out pointer at the same time. Okay, but we've used a single mutex. Right. So in some ways, maybe the best implementation of this code would have one mutex for producers and one mutex for consumers. You'd only have a shared mutex if you were manipulating the ins and outs together. If there was code that used out over here and code that used in over there, then you'd want a single mutex. Everybody sort of happy with that? So if we're, all of a sudden we didn't know about semaphores 35 minutes ago, and now we're sprinkling them all through our code, and we're actually able to now produce very sophisticated constraints, okay, about what can run in what order. And we can even allow the producer to get up to n characters ahead. We can guarantee that we only run critical sections of code in one process at a time, make sure it runs to completion. Okay, so here you see the power of semaphores. We've implemented both precedence relationships, and that had to do with the characters and space semaphores, and mutual exclusion, which we use the lock or the mutex semaphore for. Yes? If you have multiple consumers.
Does that mean that all the consumers are within the same process, or each consumer is a different process?
Each consumer is a different process, but they all share access to this set of semaphores.
Right. So doesn't that mean that if one consumer, like if one process uses a piece of data, then the other process can't because output the consumer?
Right. So in this particular arrangement, each consumer is consuming one of the characters from the buffer, and the other consumers don't see that. So that would only really make sense if somehow each thing in the buffer could be processed independently by the consumers. Does that make sense? In other words, the consumers are seeing some sampling of the things in the buffer. They don't necessarily see them in consecutive order. Every consumer doesn't get to see every character, at least the way this code is written.